In order to learn about upstream, the first thing you should know about upstream is different modes of processing. So there is batch mode, fed batch, and continuous fermentation. So you need to know what the differences are. So in this article, they basically use E. coli fermentation as an example, but they also say that uh, it is also applicable to mammalian cells at both smaller and larger scales. Um, we track the biomass and nutrient concentrations during batch, fed batch, and continuous fermentation runs. We explain different methods to analyze the process, including determination of biomass, growth rate, productivity, yield, and analysis of process cost. So these are the things you need to know. So if you're going for an interview, give me 1 second. So let's say, this area you need to know very well. This. So, oh my bad. Wait so this you need to know. So we explain different methods to analyze the process using determination of biomass, growth rate, productivity, yield, and analysis of animal. So fermentation microorganisms consume carbon sources, mainly sugar, to produce various acids, alcohols, and gases. In industry, fermentation is used to produce biopharmaceuticals, food and feed supplements, biofuels, and chemical building blocks. To establish a cost-effective process, bioprocess engineers have to consider various factors, including the cost for media and supplement, the process runtime, bacterial growth and viability, product titer and yield, and product quality. The concentrations of nutrients and byproduct in the culture medium are important influencing factors. This is why during process development, bioprocess engineers decide whether to apply a batch, fed batch, or continuous bioprocess. In batch fermentation, microorganisms are inoculated to a fixed volume of medium in a fermenter. With microbial growth, the nutrients are gradually consumed and byproducts accumulate. Therefore, the culture environment is continuously changing. The broth is removed at the end of the run. The growth curve is usually divided into distinct phases. During the initial lag phase, growth is slow as the organism needs to adapt to the new environment. During the exponential growth phase, the microbes divide at a constant rate. When nutrients are getting depleted and byproducts accumulate, growth slows down and the culture enters the stationary growth phase. At this point, bioprocess engineers usually harvest the culture. If the culture continues, it would finally enter the dead phase, which is characterized by a decrease in the viable cell density. The advantage of batch processing are ease of operation and low risk of contamination. Disadvantages are the comparatively low cell densities, which can be achieved, and the relative long downtime between batches due to cleaning, vessel setup, and sterilization. Batch fermentation is a convenient starting point for beginners in this field and is often used to optimize conditions in the early stages of the experimental design. FedBatch fermentation is a modified version of batch fermentation. It is the most common mode of operation in the bioprocess industry. Microorganisms are inoculated and grown under batch regime for a certain amount of time. Then nutrients are added to the fermenter in increments throughout the remaining duration of fermentation to feed them. The entire culture suspension is removed at the end of each run. The start of feeding is normally determined by substrate limitation in the broth, and the time profile of feeding should be designed in a way that the substrate remains non-excessive while microbial growth is fully supported.